Hi, it's Matthew Reed here from How to Repair Pendulum Clocks, and a very warm welcome to another workshop techniques video. A couple of videos ago I talked about replacing a primary bearing bushing, as clocks people call it, in an 18th century long case clock with hammer hardened cast brass. Well, today we have something similar. Today we're looking at a fusee driven clock, so a spring driven rather than weight driven clock. And what we're dealing with is when you're replacing the bearings in the clock and you've lost the original position of that bearing, how do you find out where the bearing should go? Well, the answer to that is depthing. You have to carry out a process called depthing, and that's what we're going to see in the video. Before we jump into it, a very heartfelt thank you to those of you that sent super thanks. That's always massively appreciated. You would not believe it. If you haven't before, please click the little icon down there to subscribe, like, and I love your comments. I try and get through as many as I possibly can, and I will see you at the end of the video. So here we have a reasonably regular 20th century fusee dial clock. That is a timepiece clock, just has one train of gears, indicates the time, and it's driven by a mainspring which drives into a fusee, which we'll see in a minute. So the clock landed on my doorstep like this, and when I open the bezel, you can see that the minute hand is touching the dial and the hour hand is sticking up in the air, and the winding arbor is not lined up with the hole in the dial, with the aperture. So that tells us something is pretty badly amiss. And in fact, when we look at the movement, we can see that 3 of the 4 plate retaining pins that go through the pillars and retain the front plate have dropped out. The back pivots of the arbors have mostly come out of the plates, and the wheels are in disarray. You can see the centre wheel is at quite a sort of radical sort of angle, and the clock is still half wound. So again, you can see the chain is on the barrel and on the fusee, so there's quite a lot of stored energy there, and we don't want to cause any more damage and personal injury. So to prevent this happening from you, draw file your taper pins to make sure that they don't drop out of the holes. So after a bit of consideration, there's no way to let the power off this clock as it is, because the mechanism that sets up the fusee preload is between the back of the dial and the front of the movement. We can't get to it. So with a bit of hope, I put these zip ties around the movement to try and prevent the gears from coming out of engagement. Once I've done that, we can take the hands off. And then we can remove the taper pins that retain the movement onto the back of the dial, and we have our movement liberated, still half wound. Now the arrangement for fusee setup here on the barrel arbor is a bit unusual. It's kind of a 20th century version of what went before, and I didn't have a let down tool, which is a tool for safely letting down the power off mainsprings, key that was big enough to fit this square. Now in retrospect, I should have just probably used a socket with a handle on it, but I decided for the future it could be a useful thing to have. I would make a new key. So that's what I did. With the new let down key made, I hold back the tension on the spring and take out the screw that holds the fusee setup piece in place, and I still managed to make a bit of a mess of it. Now luckily no damage was done to the clock, but as I said, I'd have probably been better off using a socket in the first place. We now have all the power off the mainspring, so we can safely take the movement apart. Once I've done that, I give the whole thing a preliminary wash, and then we turn our attention to the front fusee bearing, which unsurprisingly turns out that it's very worn. It's a replacement, and if you watched the last video in this series, I advise you to do that. If you didn't, you will know why. One of my subscribers pointed out that it could also be that the clock is overdriven, and that's a really good point, and you will know that we've talked a lot about that on this channel and over on Reed Repairs as well, and on Instagram of course. So I'm going to replace this bearing with hammer hardened cast brass, but I don't particularly trust the position of the hole, so I thought this would be a good exercise to show you an alternative way of doing it. What I do is I plug the hole with a piece of hammer hardened cast brass. This gives us a completely blank slate as to where to put our bearing hole. So that leaves us with a question: how do we know where to put the hole? Well, let's just have a little recap here. Wheels or mobiles normally mesh at the theoretical radius or diameter called the pitch circle diameter. And the pitch circle diameter, as I said, is a theoretical diameter where the mobiles would touch if they were just plain discs of material with no teeth cut on them. So in our classic 3 mobile arrangement, we've got wheel C meshing with B and mobile B meshing with A here. How do we find out where B goes? Well, we use a depthing tool and we scribe 2 arcs at what we feel is the optimal center distance. The center distance is the distance between the 2 mobiles. Where those arcs cross, these red lines here, you drill a hole and put your bearing. So we use our depthing tool here, which is a hinged-like device with points on the end, to determine by feel and through observation the optimal mesh of the gears. So spinning the wheels freely doesn't really do us any good here in terms of determining optimal depthing. The driven wheel should be under load. Once we've done that, I use the points on the end of the depthing tool to scribe an arc on our plug. So we know that our pivot hole should lie somewhere along that arc. Now we don't have another meshing mobile because the fusee is at the end of the gear train. But what I do have is the distance from the back plate between the barrel arbor and the fusee arbor. So I'm going to use that as our second line, our second arc. And then I turn up a piece of steel with a point on the end, which is a really good fit in the winding aperture in the dial. And I put that piece of steel in perpendicular to the dial and I make a small impression on the plug. And what we end up with is our 2 lines crossing, and conveniently our little punch mark as well is about 0.5 millimeter below where they cross. So we know that we're in the ballpark. Then we have to make a kind of judgment call, because this is the front bearing. doesn't have a massive immediate impact on depthing where we drill our hole. It can be where the lines cross, it can be on the punch mark, or it can be somewhere between the two. That's up to you really. So I do that. I center punch, drill, ream and broach as you've seen in the previous video, and we have our new bearing. I check for side shake and end shake on the arbor, and then really critically importantly, I check again through feel and through observation using low power magnification of the mesh of the great wheel and the center wheel pinion. Once I'm happy with that, then it's time to re-wash the clock, lubricate it, put it together and get it on test. Now, of course, because we were using a hole that was made by a previous bearing or bush, we had no control of how much of the host material needed to be taken away. In fact, we removed no more host material, but we are left with quite a thick walled bush. If you're doing this from scratch, you would try and make that bush as thin walled as you possibly can to preserve the amount of host material. So there's our movement all washed, reassembled and lubricated, ready to go back into the case. And if you want to find out more about the process of depthing, both using the depthing tool and depthing the wheels in the clock's own movement frame, and bushing, then there are extensive chapters on those subjects in our second book. So there we are. I hope that was of use. Using the depthing tool is a critical part of intermediate level clock repair. So thanks for watching. Please remember, click the icon, subscribe, like the video if you liked it and thought it was of use, and we will see you again soon.